my channel, and today I'm going to be talking about continued fractions. In our previous video on continued fractions, I talked about how to convert 27 over 23 and the square root of 3 into continued fractions. In this video, we're going to be taking this continued fraction and simplifying it into one single fraction. Then we're going to be taking the continued fraction form of the square root of 3, and we're going to be deducing the square root of 3 from it, in which we're going to be using an experimental process. Okay, so let's begin by talking about the first problem. So we want to simplify 1 plus 1 over 2 plus 1 over 5 plus 1 over 3 plus 1 over 2 plus 1 over 4. Now we want to simplify this continued fraction. Now we must reverse engineer this. We must work backwards. Okay, so let's work backwards. So we're going to be working this way. Okay, so let's start with 2 plus 1 fourth. 2 is just equivalent to 8 fourths. 8 fourths plus 1 fourth is just going to be 9 fourths. So we can say that this is equal to 9 fourths. But it is important to realize that we have to take the reciprocal. 1 over 9 over 4 is just the same as 4 over 9. But we have to add 3 to it. What's 3? Well, in terms of the denominator, we have 27 over 9 is equivalent to 3. So 27 over 9 plus 4 over 9 is just going to be 31 over 9. We can write that. So we have 3, which is equal to 27 over 9. 27 over 9 plus 4 over 9 is equal to 31 over 9. Now, we have to take the reciprocal of that. So that gives us 9 over 31. 5 times 31 is just 155. 155 plus 31, well, 155 plus 9, because 31 is now the denominator because we took the reciprocal, is just going to be 164. That's going to be 164 over 31. Now we're going to take this over here. So we have 164 over 31, take the reciprocal, that's 31 over 164, plus 2 times 164 over 164. Now the reason for doing so is 2 times 164 over 164 plus 31 over 164 is just the same as 2 plus 31 over 164, which is the same thing. And this is what we want to achieve. 2 times 164 is just going to be 328. 328 plus 31 is going to be 359. So we're going to get 359 over 164. Now we have to take the reciprocal again. So we get 164 over 359. But we have to add that to 359 over 359. Because 359 over 359 simplifies to 1. So 164 plus 359 is equal to 523. Because 4 plus 9 is 13, 1 plus 6 is 7, 7 plus 5 is 12, and 2 plus 3 is 5, because we have an extra 1 which we're carrying over. So we get 523 over 359. And this is going to be our answer. 523 over 359 is going to be this continued fraction. And as you can see, this continued fraction uses very simple numbers. It uses the natural numbers starting from 1 to 5. That's all it uses, because we have 1, 2, 3, 4, 5. But as you can see, it produces a big number. Now, we shouldn't call this a big number for one reason. Because when we put this into decimal format, this is just somewhere between 1. We can say that this fraction involves big numbers, but the thing is, this fraction over here is not greater than 2. It's actually less than 2, because we can see that 359 times 2 is 718. Now 718 is way bigger than 529. So this is probably 1 point and 1 point some numbers. So as you can see, it involves big numbers, but the decimal format of this fraction isn't that big. Okay, now that we've talked about that, let's move on to the second problem. So the answer to this problem is 523 over 359. Okay, so we have this problem over here. Now our main goal is to essentially take the continued fraction form of this number, which is the square root of 3, and we're essentially supposed to take the continued fraction form of the square root of 3 and deduce the square root of 3 from it. In other words, given the continued fraction of the square root of 3, and we don't know that it is the continued fraction of the square root of 3, how are we supposed to know that it is the continued fraction of the square root of 3? In other words, if we're just given this continued fraction, how are you supposed to know that it's the continued fraction of the square root of 3? Okay, so it's important to realize that the continued fraction of the square root of 3 is of the format 1 plus 1 over 1 plus 1 over 2 plus 1 over 1 plus 1 over 2 plus 1 over 1 plus 1 over 2, and etc. We can just continue. Okay. Now, this extends forever because we have to add a plus 1 and then divide by 1 and add plus 1, divide by 2, and so on and so forth. It keeps on going forever, and this is going to be the square root of 3. And we figured out this continued fraction in the previous video on continued fractions. So if you want to know how to find the square root of 3's continued fraction, or any square root's continued fraction, then please visit that video. But as you can see over here, we've got the continued fraction, but we don't know that it is the continued fraction of the square root of 3. So we're going to be using the experimental process to find out. So let's first draw a barrier, or in other words, a boundary. So we're going to be essentially computing, or more specifically simplifying, the continued fraction till this. Now it's important to realize that square root of 3 is approximately 1.732. Okay. So let's first simplify this. So reverse engineering and working backwards, we get 1 over 1 is just 1. 2 plus 1 is 3. 1/3 plus 1, that's 4/3. Because it's important to realize that we're taking reciprocal. 1/3 plus 3/3 is 4/3. Then taking reciprocal, we have 3/4 plus 4/4, and that gives us 7/4. So at the top, we have 7/4. Now, is this a good approximation to 1.732? Let's see. When doing this, we see that we get 1.75. Now this might seem like a good approximation for some people, but it actually isn't, because 1.75 can represent so many things. Yes, it is close to 1.732, but it's not really close that we can say that, yes, it is approximately 1.732. So in order to check this, we must go a little bit further. So let's extend our boundary to this position. Okay. So our first approximation is 7/4. Now let's continue with our second approximation by essentially reverse engineering this. Okay, so we have 1/2, let's just draw boundary before plus sign. So we have 1/2 plus 1. That's just going to be, obviously, 3/2. That's going to be 2/3 plus 4/3, no, 2/3 plus 6/3, which is going to be 8/3. This is going to be 1 well, that's 1 plus 3 eighths, which is going to be 8 eighths plus 3 eighths is 11 eighths. And we get 8 elevenths plus 11 elevenths, which is just going to be 19 over 11. Okay, so let's just check this. It's important yes, we're drawing the boundary before the plus sign. Okay, so 1/2 plus 1 is 3/2. Taking the reciprocal, we have 2/3 plus 6/3, because 6/3 is equivalent to 2, we get 8/3. Taking the reciprocal, we get 3 eighths plus, since we've done this, we have to add that to 2. Well, we got 1/2 plus 1, then we have to add that to 2. And so we have 8/3. Well, we just added that to 2, which means we have to go here. So we have to add that to 8 eighths. This gives us 11 eighths. Taking the reciprocal, we get 8 elevenths, and we have to add that to 11 elevenths, and this gives us 19 over 11, which is so far the approximation for the square root of 3. So let's essentially find the decimal format of that. So we get okay. So as you can see, we have 1.727 for our approximation for the square root of 3. Now, as you can see over here, the reason that this works particularly is because it's kind of close to 1.732. If we just ignore the place values after thousands, we just have 1.727. Now, this might seem not that close either. Yes, it is not of a good approximation, but it shows us that we're kind of approaching the square root of 3, because we get 1.727, which is kind of close to 1.732. Let's extend this a little bit more further, just to essentially see that this continued fraction approaches the square root of 3. So we got 19 over 11. This is approximately 1.727. Okay. So let's extend our boundaries to this. So the new red boundary. That's all of this. So let's do this. So we have let's erase this first. So we have 1 plus 1/2. That's just going to equal to 3/2. Taking the reciprocal, we get 2/3 plus 6/3, which is going to be 8/3. We have 3 eighths plus 8 eighths, which is going to be 11 eighths. We have 8 elevenths plus we're going to have 16 elevenths. That's 8 elevenths plus 16 elevenths. That's 24 over 11. Because this is 11 eighths, next we have to take the reciprocal. That's 8 elevenths plus 16 over 11. That's 20. 8 elevenths plus, that's going to be 8 elevenths plus 22 over 11. That's going to be 30 over 11. Okay, that's going to be 30 over 11, and that's 11 over 30 plus 30 over 30, that's going to be 41 over 30. Now, 30 over 41 plus 41 over 41, that's going to be 71 over 41. So we get 71 over 41 as our approximation. Now, let's just test this in the form of decimals to see if this is close to 1.732. Okay, so as you can see, we have 1.731 as our approximation for 71 and 41, and this is very close to our approximation of the square root of 3, which is 1.732. So we can see this continued fraction does equal to the square root of 3, because the smaller fractions which we considered are approaching the square root of 3. And so if we were to essentially take an approximation for the square root of 3, we could use 71 over 41. Same for pi. The common approximation for pi is just 3.14. Well, that's the decimal approximation. And the fraction approximation is 22 over 7. And that's really useful when we're just dealing with rational numbers, because that is an approximation for pi, which is a rational number. We can essentially use 22 over 7 for a variety of things when we just want rational values or integer values. If we have integer values, that's 7 times 22 over 7, which simplifies to 22. So 22 over 7 is a very good approximation for pi. Similarly, 71 over 41 is also a very good approximation for square root of 3. Now that we've talked about that, we can make this video to an end. If you like this video, if you like this channel, please subscribe to learn more. Thank you.